Hello, welcome to the second part of our unit on circuits and DC instruments. In this section, we're going to be introducing the concept of equivalent resistance and using that to analyze very simple circuits. So, equivalent resistance. When you use equivalent resistance, you combine all the resistors in a circuit using the series and parallel rules down into one resistance for that circuit. This method of circuit analysis works when you have a single battery and resistors and nothing else. So let's do an example, a very basic example, where we have three 10-ohm resistors. Those can be connected in 4 different ways using series and parallel combinations. We want to find those 4 ways and determine the net resistance or the equivalent resistance for each case. So starting with one of the obvious ones, I can put 3 10-ohm resistors in series. Label this with a 1 so we know it's combination 1. So now I'm going to combine those down to a single resistance where our series is going to equal 10 ohms plus 10 ohms plus 10 ohms, which combines to give me a equivalent resistance for that combination of 30 ohms. The next method is the 3 resistors in parallel combination. So I'm going to combine those down into one resistance. I'm going to call that R parallel, where 1 over R parallel equals 1 over 10 ohms plus 1 over 10 ohms plus 1 over 10 ohms, which equals 3 over 10 ohms. So R parallel is 10 over 3 ohms, or if you prefer, 3.33 ohms. Now we have to think a little bit more because we've done series, we've done parallel, now we need to start combining the two. One of the 2 combinations involves 2 resistors in series in parallel to a single resistor. So now to determine the equivalent resistance of this, I have to take 2 steps. The first thing I'm going to do is combine these 2 10-ohm resistors into a series combination. That series combination will be in parallel with the original 10-ohm resistor. Now I can take and combine those down into one resistance. So beginning with my calculation by calculating the series resistance, that's going to be 10 ohms plus 10 ohms, that's 20 ohms. And now 1 over R parallel will be 1 over 10 ohms, that's this guy, plus 1 over our series resistance, which is 20 ohms, which is 3 over 20 ohms. Remember that 1/10 is 2 over 20, which means R parallel is 20 ohms over 3, and that equals 6.67 ohms. The last combination number 4 is 1 resistor followed by 2 resistors in parallel. So again, like in the previous combination, I have to take 2 combinations. Keep that original 10 ohm resistor, that's this guy copied over, and I'm going to combine these 2 in parallel. And now I can combine all of this in series. calculating the parallel combination first. So our parallel is 5 ohms. And now I can calculate our series is going to be our original 10 ohm resistor plus our parallel, which is going to be 5 ohms. And that's going to be 15 ohms. So notice 3 resistors in each of the 4 cases. But depending on how I combined them, how I connected them, determined the overall resistance. And we had a low resistance for the combination for the 3 in parallel at 3.33 ohms. And we had a maximum of 30 ohms for the 3 in series. So the thing to remember, the thing I'm trying to get across to you here, is that the number of resistors matters, but the number of resistors and how they are connected matters more. In the next unit, we're going to do a bigger example of equivalent resistance.